So 10H is all about conditional probability. So you want to make sure, first of all, to get this all in your notes. So conditionals really, if you want to underline this part, conditional probability, because the probability of I is occurring on the condition that F has occurred. All right, so for example, if we have this Venn diagram over here, it says this shows which students in a class study Italian and which ones study French. So this is the Italian, this is the French, so this would be the both, the intersect, and there's one that doesn't study either. All right, so if we want to say the probability of Italian given that French has occurred is just the number of students who study Italian and French given that we know that they actually study French. It makes a little bit more sense when we get started here, but one of the things is this notation, this straight line here, I will tell you that anytime the words given B has occurred, they want you to be able to recognize conditional probability. So you always are going to get a pity point or a method mark if you recognize conditional probability. So just writing this formula out when you see the word given is going to give you some points. All right, if you need to pause it to get the rest of it, I'm going to go ahead and move on. To me, this ends up being extra, so you do not need this part. Sometimes we use it, but I'm just going to say this is just going to be the main one we use. Okay? So this was just more the number of each. This is showing the actual probability of each. Okay, so first of all, this is going to be a tougher Venn diagram, and let's read through the problem and see why. In a town, 25% of the residents own a cat, 55% own a dog, and 30% do not own anything. The part that's missing is it does not tell us how many own both. So I'm going to draw two Venn diagrams. Cat, dog. The easiest part of this is neither. 0.3 goes kind of in that bottom because it does not fit in either one. So I know that inside the whole circle is 0.25 and the whole D circle is 0.55, but I don't know how many are in both. So I'm going to call that X. So that means whatever's over here is 0.25 minus X, whatever they have in common. Because remember, your entire circle has to be a total of 0.25. So that means the dog, 55%, is 0.55 minus X. So we're going to use this situation to write an equation, because if we add everything up, I know it's got to always, my Venn diagram always has to equal 1. So that allows me to solve for both. So I take cat without both, plus both, plus 0.55 minus X, plus 0.3. So I'm adding up every single thing that we see to get 1. All right, once we do that, I'm going to combine my like terms. So these cancel out. When I put my 0.25, 0.55, that's 0.8. And 0.3 is 1.1 minus X equals 1. So then I add X to this side, minus 1 from this side. So I get 1/10 for my X. So now let's revise our Venn diagram. And we have our cat, and we have the dog. We now know that they both share 0.1. This is still 0.3. So the ones who just own a cat is our 0.25 minus 0.1. So that's 0.15. My just dog is 0.55 minus 0.1. So that's 0.45. All right. So all of this work here was kind of extra just to get to this finished Venn diagram that we can figure out our answers now. So I'm going to erase some of this. If you need it to kind of process, stop the video. Now we're going to use our finished Venn diagram to answer letter B. All right. So what's the probability is if they own a cat given they own a dog? All right. So one of the things, the good thing for you guys is you're going to have the formula booklet always to use on your tests. But the probability of dog always goes into the denominator. So I would write probability of cat intersect, dog over the probability of owning a dog. So it's kind of like you just take this C/D and tilt it. This always goes on the bottom. Just D goes on the bottom. All right, so if we look at our Venn diagram, this portion is our intersection. So that's our 0.1. Probability of cat and dog is 0.1. Divided by just the probability of the dog is 0.55. And if we divide that, we get approximately 0.182 if we go 3 sig figs. All right, now let's do BI. Probability they do not own a dog. So I'm going to say D complement given they own a cat. All right, so the probability they don't own a dog, I'm just going to cross all of the dog out and I just add up everything that I'm left with. Oh, given they own a cat. So actually we can think of this differently. How about if we do this? If we know if they're given that they own a cat, it has to be in this circle somewhere. That they don't own a dog is just right here. So 0.15, own a cat, but they don't own a dog. So out of the ones who own a cat total, only 0.15 own just a cat. So we can go through and use this formula and go through the whole thing. But what this does is it isolates where we don't even have to worry about this part here. So it just kind of gives you another option, I guess. All right. 22, we're actually going to use, we've got 2 situations. The top shelf in a cupboard contains 3 pumpkins. So let's kind of label this out. So the top has 3 pumpkins and 2 chicken. The bottom shelf has 4 pumpkin and 1 chicken. Lucas is twice as likely to take a can from the bottom as he is from the top. So that's getting into the probability of choosing the top versus the bottom, because that's our first thing we've got to figure out. So if he's twice as likely to take from the bottom shelf, that means our bottom has a 2/3 probability versus the 1/3 for the top, because if the bottom is twice as much as the top, that's what we have to have for our probability. All right, so then when we pick from the top or bottom, the top has, we have pumpkin or chicken. So we have pumpkin is 3/5, chicken is 2/5. And on the bottom shelf, we have pumpkin is 4/5 versus chicken 1/5. All right, so first we're just looking at what's the probability that it is chicken. So we change, I'll go to this. So this is just getting, the tree diagram just gets us all set up. So if we just want to find probability of chicken, I can either do the top and get chicken, or I can do the bottom and get chicken. All right, so if I do the top, that's 1/3 times 2/5 plus adding in the bottom, 2/3 times 1/5. Is this, there's no probability or conditional in letter A, it's just the probability of chicken. So that's 2/15 plus 2/15 is 4/15. All right, so our probability of chicken total is 4/15. And letter B, almost done. The probability top given chicken is just going to be the probability that I did the top given chicken is 2/5 divided by my bottom, which is 4/15. The probability of just chicken is going to be multiplied by the reciprocal. Oh, this should have been 15.
Janet, Laura to the attendance window, please. Janet, Laura to the attendance window. Thank you.